Hey, it's Dr. Gold. We're now up to what probably and arguably is the really most important chapter or chapters that are coming up here in the textbook, which deal with the time value of money concept. This is a really critical part of the course because it's going to enable you to be able to excel on the exams. It's going to enable you to learn so much about financial forecasting, both on a personal level as well as professional. So please try to read in great detail the chapters that are coming up here in Module 5 and 6 because I think it'll provide you with a solid base moving forward. The time value of money concept basically argues a couple of things. One is that a dollar today is worth more than a dollar tomorrow because you can invest something today, and earn more money on that. So over the course of time, time has value and therefore it becomes worth more by accepting the dollar today. The time value of money concept, more importantly, deals with concepts of future value and present value and basically allows you to engage in virtual time traveling. So for example, someone might say to you, I have in the present $100 and I know I can earn 10% for the next 20 years. How much will I have at the end of 20 years? Now, if you were just using simple interest calculations, which we don't use all the time, especially in finance, because our money is compounding, and compounding basically means earning interest not only on the original present value investment or dollar amount that was invested, but also on the interest. So, after 1 year, your $100 has grown to $110. So in year two, you earn another 10%, but not on $100, which would be simple interest, but rather on $110, which would be $11. And I know it sounds like it's just $1, but over many, many years, compound interest obviously adds up to a significant difference. If we were using simple interest in that example and someone said, well, I have $100 today, I know I can earn 10% for 20 years, how much will I get? Well, you're going to get $10 a year for 20 years, which is $200, and you started out with $100, so at the end of the 20 years, you'd have $300. But obviously, when you earn interest on interest, not just on the principal amount, well then all of a sudden that amount would be much larger than $300. So let's go through a couple of basic things here. First is a timeline. A timeline is a good visual representation here of mapping out problems and understanding these concepts. You'll see here on this particular timeline something called PV. That stands for present value, and it's above the number 0, which is the present. It's at the starting point. It's the beginning of everything. The money you invest here, it looks like just $1. It hasn't had time to earn any interest or work for you at all. And then you have different numbers along the timeline. These are called periods. Typically, people think of periods as being years. Like this would be 1 year and 2 years and 3 years and 4 years. And many times that is the case, but oftentimes periods could be months, periods could be hours, days, years, and so forth. So don't get too wedded to the notion that a period equals a year. It could equal a month, it could equal a 6-month period of time, and so forth. And you'll see when we cover the examples in this chapter why that's the case. Over on the right-hand side of the timeline, you have future value. And you can see that the pile of money here is larger than at the beginning, at the present, and that's because of compound interest. It means that you started out with $1, let's say, you earn 10% on the dollar, so at the end of 1 year you have $1.10, and then you earn 10% on the $1.10, and so on and so forth, and you end up with a larger pile of money at the end of the rainbow. Now, PV, which stands for present value, as we just talked about, sometimes you'll be asked to solve for present value. where you don't know how much something in the future is worth today. So someone might say to you, I have an investment for you. It will require you to invest today $100, and it will be worth X number of dollars at some point in the future given a certain rate of interest. Well, before you just give the person that money, you have to figure out, let me time travel into the future. What is the dollar amount the person's promising me? And let me use the rate of interest they're telling me to discount backward into the present to see what that investment should be worth today in the present, so I know if I'm making the right investment or not. These are the formulas underneath here for present and future value. And whether or not you're discounting or compounding, compounding is always going to be when dealing with future value calculations, and discounting will always be associated with present value calculations. There are always going to be 5 different criteria. 4 are shown here because one of them we don't really go through any practice questions for in this chapter. But I'll show you on the next page what the 5 are. The first one is PV, which is, again, present value. You should always write these 5 things down when asked to solve for a question related to the time value of money, because it'll help you to understand and identify what it is you're trying to solve for. FV equals the future value. PMT, which was the one missing on the previous slide, stands for payment. Now that might be, let's say you have a investment strategy for yourself to build a retirement nest egg, and you start out with $100, and you say to yourself, each year I'm going to deposit or make a payment into my investment account of $100 for the next 40 years. And I'm going to earn X percent over that period of time. How much will I have? Well, you know, you're going to have quite a bit of money if you're making regular payments and they're sizable payments. Another way of looking at payments would be, of course, through mortgages. We make monthly payments when we have mortgages. So a payment is any type of a distribution of money that's leaving your world, let's say through a mortgage payment, or coming into your world, which might be, say, a dividend that you're receiving from a company whose shares of stock you own. But don't worry too much about payment for now, because we're going to cover mostly present value, future value, I, which stands for the rate of interest. The rate of interest will always be viewed as compounding when you're solving for future value, and discounting when you're solving for present value. And then, of course, N, which is the number of periods. So I'm going to stop this video here, and then we'll pick up with practice questions in the second video.